Hello students, today we see some problems on pH calculations. Okay, see the first one. So the 100 milliliter of pH equal 3 and pH equal 5 means 100 milliliter of two solutions. One is having pH equal 3, other having pH equal 5. Solutions of an acid are mixed. So what is the resultant pH? What is we have to find out what is the pH of a mixed solution. So here both are acids, both as acid mix. The final solution nature will be acidic nature. So final concentration will be concentration of H plus. So the H plus equal, we know that both are acids, N1 V1 and 2 V2 by V1 plus V2. So here substitute. So what is the normality of first solution? So here see V1 is given 100 milliliter, V2 also exactly given 100 milliliter. So what is the N1? So N1, how to find out N1 means the first concentration is given. For first solution it is given pH is equal to 3. pH equal to 3 means it is minus log H plus equal 3. So therefore H plus equal 10 power minus 3 according to mathematical rules. In the same way, how to find the N2? So N2 for solution 2 it is given pH equal 5. pH equal 5 means minus log H plus equal 5 and H plus equal 10 power minus 5. So this is N2 and this is N1. Okay, so the N1 equal 10 power minus 3, N2 equal 10 power minus 5. So substitute in equation 1. Substitute in equation 1, the final H plus concentration equal to, what is the N1? V1. So it's N1, what is the V1? V1 is 100. Next, what is N2? 10 power minus 5. V2 is again it is also 100 milliliters by V1 plus V2 total volume. Okay, next to the calculation. Therefore final H plus, just take the 100 common and we also take the 10 power minus 3 also we can take the common, 10 power minus 3. Now it becomes 1 plus 10 power minus 2. Okay, by taking 10 power minus 3 common it becomes 10 power minus 2 only. Here it becomes 200. Okay, so finally we get 10 power minus 3 plus 0 point by 2. So that is 10 power minus 3 into that is 1.01 by 2. So 1.01 by 2 is nothing but equal to 5.05. Just wait. So this value 1 by 0.505. So we can make it 10 power minus 4 into 5.05. So the final, this is the final H plus concentration. With the help of H plus concentration and substituting the pH formula, we can do the final pH. We can take it as a step 2. Okay. So pH is equal to minus log H plus, so therefore that is equal minus log, so substitute here, this is H plus concentration, so we know that log A into B, just minus log A into B means log A plus log B. This is minus log 5.05 become plus, so minus already, minus log of 10 power minus 4. Okay. So the log 5.5 value here approximately that is 0.7032. Okay. So this comes to the front one, 4 log 10. We know the log 10 value is 1. So minus 0.732 plus 4. So on the subtraction we will get approximately 3.3. Okay. So this is the pH of a final solution, means both acids are mixed, so final solution will be acidic. Okay. Let's see the next one. So calculate the pH of 0.001 m aniline. Actually aniline means C6H5NH2. So no need of the compound, just I am giving the formula. So what is the ionization constant? What is the ionization constant of anilinium cation? So given that Ka of that is 3.5 into 10 to the power of minus 10. So here it is given that pH of 0.001 m aniline, we have to find the pH of 0.001 m so aniline solution, and also have to find what is the ionization constant of anilinium cation. So it is given for acid. For acid it is given as 3.5 into 10 to the power of minus 10. Okay. So the pH so here see, so I have to find the pH of aniline. So in the problem actually it is given Kb, not K, so it was a print mistake in the book, so it is a Kb. So we know that it is a weak acid. How we are knowing it is a weak acid means its Kb value is given. So Kb value is given means nothing but it is a weak base. If Ka value is given, it's a weak acid. So it's a weak base, 0.01 m aniline. Aniline is a weak base. So therefore we know that OH minus concentration for weak base is equal to root Kb into C. So that is root Kb how much? 3.5 into 10 power minus 10. What is the concentration? 0.001. So make it 10 power minus 3. So 3.5 10 power minus 13. So make it 35. Here we are increasing, here we are decreasing. Okay. So 35 approximately take as a 36, and root 36 is 6. 10 power minus 14. 10 power minus 14 means 10 power minus 7. So therefore the OH minus ion concentration is 6 into 10 power minus 7. So then with the help of this OH minus concentration we can find the POH. So POH is equal to minus log OH minus 7 log 10 okay, here the log 6. So what is the log 6 value? Find that is given. So minus log 6 plus log 10. We know the log 10 value is 1. The log 6 is approximately, here it is given. So the log 6 value is 0.778. So therefore here we get final POH. The POH equal to 6.2219. So we know that relation between pH and POH. So take it as a third step. So pH is equal to 14 minus POH. So the pH equal 14 minus 6.2219. So pH equal to 13. 7.778. So approximately it is given as a 7.8 in the options. Okay, means it is given the base. At first it is given the base, so we calculated the OH minus concentration for that weak base with the help of Kb and its concentration. Next we calculated the POH, and finally we calculated the pH with the help of the POH value. Okay. Okay, see the next problem. So calculate the the dissociation constant of a weak acid. It is given all it is a weak acid. Just the weak acid mentioned as HA. Its K value, dissociation constant, is given as 10 power minus 7 and 10 ml of this aqua solution. The ml of aqua solution of pH equal 4 so is added with 990 milliliter of water. Final pH equal how much? So it is simply on dilution. We know that the concentration of H plus decreases. So we have to find the pH of that final solution. So what is the formula for dilution? So on diluting an acid, so we know that formula is N1V1 equal to N2V2, but it is given. We don't know the initial concentration. At first we have to find the initial concentration. Okay. So first step is calculating initial concentration. So initial concentration, how much? The H plus equal to, so it is a weak acid, its dissociation constant is given, K is given. Next, we don't know the concentration, so but it is given H plus equal to root K is given, so there is no particular H plus. Okay, so and it is taken 10 ml, its pH is equal to 4. Means so its pH is given as 4. Okay, pH is given as 4 and its Ka is 10 power minus 7. So H plus equal to, we know that root Ka into C. Okay, so the K value is how much? What is H plus? pH equal 4 implies H plus equal to 10 to the power of minus 4. So substitute in this equation, 10 power minus 4 equal to root K, that is 10 power minus 7 into C. Okay, we have to find the initial concentration. So what is on squaring both sides? Squaring both sides, we will get C it equals. See then what about the concentration? So finally we get the concentration 10 power minus 1, that is a 0.1. So the concentration of H plus, the concentration of H plus in the initial position, that is 0.1 m. So from this solution they took 10 milliliter. They took 10 milliliter and it is added by 990 milliliter of water. Okay, so after adding 990 milliliter of water, the final solution becomes 1000 milliliter. We have to find the concentration of that 1000 milliliter solution. Okay. So initial concentration M1 equal to, we got 0.1 m. So what is the V1? How much volume of that solution is taken? 10 milliliter. What is the M2? We have to find that final concentration. After concentration we will get the pH. Okay, first we have to find the M2. Then we find the concentration. With help of concentration we find the pH. So what is the V2? 990 plus 10, that is 1000 milliliter. So we know the relation M1 V1 equal to M2 V2. I have to find the M2. So what is M2 equal to? So 0.1, this 10 becomes 1, means it becomes 10 power minus 3 m. Means the final concentration, the final H plus equal how much? So the final H plus, in the final solution H plus equal 10 power minus 3 m. Okay, the final solution is having 10 power minus 3 m. We know that what is the pH? pH equal to minus log H plus. So finally we get pH equal 3. Means so it is, we are doing it in 3 steps. First we calculated the with the help of Ka value we calculated the concentration of that solution at initial position. Next we used M1 V1 equal to M2 V2 for the final, to know the final concentration. Like that final concentration is used to calculate the final pH. Okay. Let's see the next one. 200 milliliter of aqua solution contains 63 milligram. 63 milligram of HNO3. So find the pH of that acidic solution. We know that HNO3, so it is directly acid, but it is concentration is not given. At first we have to find the concentration. So concentration in terms of molarity we have to find. Molarity is equal to, what is the formula? Weight by gram molecular weight. The volume is given in terms of milliliters. So 1000 by volume in milliliters. What is the molarity? What is the weight? 63. So it must be in this formula we have to take the weight in terms of grams. So 1000 milligrams. So I get 10 to minus 3 gram molecular weight of HNO3 63. So what is the volume? 200 milliliter. So it becomes, what is the molarity? 5 into 10 power minus 3. Molarity means nothing but it is a H plus concentration. So molarity of HNO3 means the H plus concentration equal to 5 into 10 power minus 3. Then what is pH? Final we got that is equal to 2.301. Okay, see the next one. Hundred milliliter of 0.2 N H3SO4 and 150 milliliter of 0.5 N. So that are both same acids. So find the final pH of the resultant solution. So here also both acids are mixed. Here important thing is H2SO4 actually dibasic acid, but already it is given in terms of normality. So there is no need to multiply the concentration with the basicity. So జనరల్గా మనం మొలారిటీ కాన్సన్ట్రేషన్లో ఇస్తే దాన్ని బేసిటీతో మల్టిప్లై చేసిన తర్వాత we do the problem. But here already it is given in terms of normality, so no need to multiply it. So the H plus equals 0.38 we got. So fine. Substitute pH. So the logarithm of 0.38. So actually, already we know the actually this type of logarithm values. We have to actually remember logarithm values up to 1 to 10 only. So that's necessary. But some middle values or other values will be there. So they will be given, their values will be given in the problem itself. Okay. Or otherwise we provide the logarithm sheets are also there. Okay. But here we have to take the direct value. In maximum exam they will give the logarithm value other than 1 to 10 values. The logarithm of 0.38. 0.38 is so log 0.38 is minus 0.42. So logarithm values are also present in negative values. So 0 point something values or all are having logarithm values in negatives. Okay. It becomes 0.42. Sorry, it is a pH, not H plus. So the pH equal to 0.42 means it is a strong acid. Let's see the next one. So calculate the pH of a mixture. Mixture containing 30 milliliter of 0.1 m KOH. So potassium hydroxide and 50 milliliter of 0.2 m HCl. So in this problem, one acid is mixed with another base. So in this problem, at first we have to find the total solution is acidic or base by comparing their milli equivalents. Okay. So first find the normality into volume of acid. This is called milli equivalents of acid. Okay. So what is the volume of acid? 15 to what is the molarity? So normality actually. So normality, it is given molarity and normality equal for HCl because its basicity is only 1. So volume 0.250. So here we get how much? 10. Is it 10 millimoles? Okay. Next, what is the base millimoles? Sorry, milli equivalents. Milli equivalents of base how much? It's normality, it is given molarity, but its acidity is 1. So directly we can take it as a normality. It is 3. So here NaVa is greater than NbVb. So therefore final solution is acidic. How much acidic character remained in that? NaVa minus NbVb by Va plus Vb. Already we done this calculation. What is the total volume? 50 plus 30. So on this calculation, how much we are getting? 0.0875. So you must be very perfect in the calculation. That's also very important in the exams. 0.0875. make it 875 into 10 power minus 4. So it becomes minus log 875 plus 4 log 10. So simplification is also important. So here minus log 875. Log 875 is given as a 2.94. Log 10 value is 1. So finally we got 1.06. The final pH of the solution is 1.06. Okay. So these are the important problems. There is some more problems are there. So minimum it take more 2-3 classes to complete the all problems. Okay. But try to practice them at least 2 to 3 times.